I'm now going to introduce our speakers for this session. Their full bios are available in our workspace and website, but I'm going to give you a few highlights. Our first speaker, Mr. Darlington Akogo, is the multi-talented founder and executive director of artificial intelligence at Gudra, G-U-D-R-A, and Mino Health for democratizing quality healthcare in Ghana, and is the lead for artificial intelligence for radiology at the United Nations International Telecommunication Union, as well as the WHO focus group for artificial intelligence for health. Our next two speakers will co-present. Dr. Amir Kimia is an emergency medicine physician. As part of Boston Children's Hospital's Clinical Informatics Fellowship Program faculty, he applies and exposes clinicians to natural language processing in clinical research. His colleague, Mr. Asaf Landschaft, is a software developer and data scientist in Germany. As medical research collaborator at Boston Children's Hospital, he uses ML and NLP algorithms for research and workflows. Our final presenter is Dr. Yasser Ayaz, who is professor of AI and robotics at the National University of Science and Technology in Islamabad, Pakistan, and is chairman and central project director of the government of Pakistan's Top Tech Initiative in Artificial Intelligence. He's also founder of the IEEE Robotics and Automation Society in Pakistan. His research in motion planning and humanoid robotics has over 100 international publications and many patents. I want to remind you that there'll be no breaks between presentations, and I would now like to welcome our first speaker, Mr. Akogo.
Thanks for the introduction. Hello, everyone. So, I hope I'm getting the, I would like to cover AI in Africa, the potential, but also the challenges as well. Do I have screen control? It's not.
You should be able to accept it now.
Okay, yeah.
Perfect.
So, we will start by talking a bit about just generally healthcare in Africa. My screen hasn't changed yet.
I do not show that it's connected, so I'll drive for you. Just let me know when to change your slides, sir.
Okay. But it says yes that I can control your screen. Let me see. So yes, this is perfect. Yeah, so from recent statistics, Africa had about 9 million deaths. This is from last year, so pre-COVID-19. Of that 9 million deaths, basically a little over half of it, about 5 million, usually come from infectious diseases. Then you have about 30%, which is about 3 million dead that come from non-communicable diseases like stroke and other diseases as well. So to be able to address this death as well as the challenges that are being faced in healthcare, diagnostics and radiology is of utmost importance. About 50 to 70% of clinical decisions usually depend on accurate laboratory diagnosis. However, the reality is that globally, but then also especially in Africa, there are a lot of issues around misdiagnosis as well as misdiagnosis. So with misdiagnosis, somewhere several years ago, a study found out that it was only about less than 1% of South Africans were reported to have sickle cell anemia. But then they found out later that 1% that reported, those who actually ended up having anemia were over 300% the number that they found out. So there were a lot of people that had sickle cell anemia, but then they were missed. The diagnosis, they weren't able to capture that thanks to misdiagnosis. Next slide. I think, yeah, so the next one is the misdiagnosis. So another study from years ago found out that 40% of children that were diagnosed of having malaria in Accra, or sorry, in Kumasi in Ghana, actually had bacterial sepsis. So this is also another major challenge. So it's quite clear that there are a lot of interventions that are needed, and then AI poses a lot of opportunities. So another reason why AI is even more apparent in Africa is that if you look at our doctor or medical expert to patient ratio is quite absurd in all honesty. So if you take, for example, Ghana, we have about 11,000 patients to one doctor ratio. Malawi, which has the worst in Ghana, in Africa, actually has 60,000 patients to one doctor ratio. And South Africa, which is some of the best economies in Africa, basically has one radiologist for every 100,000 people. In Ghana, you basically have one radiologist for every 800,000 people. So these numbers makes it difficult to actually have the human experts, the human physicians be able to truly engage and then make healthcare accessible. So technology becomes a no-brainer.
Okay, thank you for having me. We're going to be presenting a piece of AI, which is going to be primarily natural language processing, and how to make it approachable to the fingertips of the end user. We'll start with describing the very basic unit. Small hospital unit is going to be an ALS truck or an ambulance. And we're going to start with one simple disease, which is going to be out of hospital arrest. It'll be a person dropping in the street, an ambulance going to be getting that person into healthcare, and that alone is going to start generating data. I'm going to need your help, Johnson. I'm not getting control over this slide. So next click, please. What is the data that we should be collecting has been already coined by a consult that recommended to have about 11 items called Artstein variables named after the person who coined them. Next slide. These include whether there was resuscitation down at the scene, whether an automated defibrillator was used, did the patient respond to the intervention, and what happened are sort of examples of these events. Next slide. And so these data are key to understanding the critical element for resource management. How many trucks like this do we need? Where do we need to have our defibrillators? Do people know about them? All these things can be elicited from that one document that is dealt from one encounter based on one disease process. Next slide, please. And next slide. There's two types of data that are collected in our scenario. There's numeric or categorical data that is structured. It could be the demographic of the person. It could be their blood pressure, their heart rate, and some checkboxes that people wanted, or usually system designers were people to click on so they can collect data. Oftentimes people will pass on these because they want to tell a story. There's limited stuff you can do with the structured data. You can probably get something about the demographics of the people you're rescuing and so on and so forth. But the average blood pressure of people dropped in the street, does that really matter? Probably not. Next slide. But there's the medical narrative, what is put in the report that contains most of the information. There's the patient's story. What happened? What are their background illnesses? What was the setting in which this event happened? What happened at the scene? Who witnessed it? What did they see? What did it look like? It might not have been a cardiac arrest. And then what the paramedic wants to tell you, or the clinician, what I've done, why did I do it? Why did I choose this strategy over other? Why did I choose this medication? And then what happened between the time I put this person on the truck until they brought him to the emergency department, which in that case is to me. That person who generates these stories as a representative of the patient and of himself is the person who knows the data best.
Yes, so what have we done in this specific project, just to wrap it up? We have deployed software in the specific state organization that was doing this ambulance optimization project. We trained the staff member there. The training took something like 3 or 4 hours. Then the staff member, well, there were a couple of support calls, but the staff member managed to train by herself several models that extracted most of the variables that we were supposed to extract for this ambulance optimization project. Since I'm collaborating with Dr. Kimian, we have done it more than 50 times in 50 similar projects. So what are the challenges? So this slide summarizes one of the challenges, and this is the conflict between, or the opposite trends in AI. On one hand, there is the trend towards deep learning, which are the state-of-the-art algorithms, also natural language processing. But these algorithms are harder to train. They require large amounts of data, special hardware, and their interpretability and explainability, which are two important qualities that we look in AI deployed in healthcare, sometimes are very limited. Not all the time. There are some deep learning algorithms in natural language processing, for example, distributional semantics, that really makes sense for the practitioners that write the clinical notes. But sometimes those CNNs or RNNs and so on are hard to interpret. On the other hand, there is the trend towards simplicity. As I said, explainable algorithms, for example, random forest, support vector machines that have some kind of geometrical sense. Those algorithms normally can run on standard hardware and require less data to train and to start to provide a meaningful result. And what we would like to do is to sort of eat the cake and leave it as a whole. So we would like to get the best performance, the best accuracy, specificity, and so on from the algorithms, but still put it in the fingertips of the people that generate the nodes that sometimes have limited resources, limited hardware. Next slide, please. This slide I already covered. It's what we have done in this specific project. Next slide, please. Yes. So the last challenge that I would like to tell you about is the creation of workflows and user interfaces that are usable for the people that generate the nodes.
And now we'll transition over to Dr. Ayaz.
Thank you, Johnson. It's a pleasure to be here. Thank you, Johnson. It's a pleasure to be here and to speak to all of you. And I'd say that these are tough times because of the COVID-19 crisis, but also the attention paid to the digital connectivity has enabled us to speak to each other while we are so far away. And that's, I guess, one of the rare opportunities. So I'll be speaking on the topic of artificial intelligence for everyone. And I'll focus my talk towards the big realm of artificial intelligence and how it extends beyond just data interpretation and beyond just recognition of stuff from images, but also to cognition and action and robotics and how artificial intelligence is changing the world. So a little bit about myself, first of all. Okay, so let's wait for the slide to go to the next one. There's a little bit of delay because the connection is from, I'm here in Pakistan and on the slides over that server. So I'm a professor of artificial intelligence, central project director of the National Center of Artificial Intelligence, which is Government of Pakistan's initiative. I'll take you through what it is in the next few slides. So I chair the IEEE Robotics and Automation Society in Pakistan too. And my alma mater is Tohoku University in Japan. So I was studying there for my PhD, and I still have continued my relationship with them. And I'm a specially appointed professor there too. So this is the National Center of Artificial Intelligence is not just located in one place, it's a big center, and the laboratories in this center have been selected on competitive grounds by the government of Pakistan. And by virtue of sitting at the central place in the capital in Islamabad and having a look at all the professors, we are a team of more than 230 people applying artificial intelligence to different kinds of applications, ranging from medical diagnosis to surveillance to criminology, safe mining, robotics, stuff like that. So I'll take you through, how the world is evolving in AI, how areas are being explored, and how AI is being applied to all those areas. And in one way or the other, the applications are interconnected. So that will be the focus of my presentation. So yeah, that's just me in my Japan years. So my entry into the world of artificial intelligence was through robotics. So ever since in my bachelor's, I was studying robotics and mechatronics, and I was fond of working on human-like robots. And then I started by making robots, and then I started controlling them. And when I ultimately went to my PhD, so the picture on the left shows you the robot that I was working on during my PhD. I've spent 4 years in Japan working on this one. It's called HRP2. So my work at that time was trying to navigate around environments and, train robots to go over obstacles, recognize what's there in the environment, dodge it, and, not collide with stuff. And also, of course, with the objective of the robot existing in a human environment. It could be a home, it could be an office, it could be a hospital, and assisting human beings in a lot of tasks. You see that, for example, just for in the COVID-19 scenario, how useful this kind of a technology can be, because it can help doctors keep a social distance from people and still be able to serve them. Had it been, mature to that level at this time, it would have been really great. I've been in communication with some doctors in the US as well. They were looking for simpler tools. There are some robots available, but well, this is not the focus of this particular presentation. So. Next up is I transitioned from this over to another project, which is humanoid robots playing soccer, right? So this is the RoboCup project. RoboCup is the Robotics World Cup, actually, and its topmost league is played with humanoid robots, these small little bots. There are 6 of them on one side, 6 of them are on the other side in a team, and they play soccer autonomously without any human intervention or control. You can't even hook up an external computer with a robot to control the robot from there. So on very limited computational resources, the robot has to do all the computation. It has to decide when it is looking at the field, it has to see which other players are there. Are these players part of its own team or the opponent's team? Then the robot has to decide whether it has to give, for example, pass the ball over to one of its teammates. How to accurately do it is a whole new level of question. For example, if he kicks the ball too hard, if the robot kicks the ball too hard, the ball would pass, in front of his teammate and maybe go to the other team or cross the line. From starting from these small little things, AI actually extend to sensing, cognition, as well as action. So all these 3 domains are there. Most of the time when we look at AI, we think that it's just data analysis, and there's a lot of data, and we crunch through it, and we make some sense of, what the data patterns are. But actually AI extends, a long way from that. So this project was covered in a lot of places because this was the first ever team from South Asia that made it to the topmost league of this competition, the RoboCup competition. In the US, there are universities participating in this competition. Some of them are University of Pennsylvania, UT Austin, Carnegie Mellon was there, but they're not competing in this league anymore. Like a number of other universities from around the world in Japan, China, from South Asia, you were the first one. So this just covers like my background about how I entered into artificial intelligence. So now I have the privilege, I'm lucky enough to sit at the top of this National Center of Artificial Intelligence and look at AI streams and AI evolve in different areas, people with expertise from various parts of the world and how they're applying AI to solve different problems for humanity.